Yes, here, good afternoon everybody, and welcome to electronics online classes. Look here, in the last class we are discussing about the crystal oscillator, and as I said already, as compared to the LC and RC oscillator, we will prefer more about the crystal oscillator. And why you are giving more importance to the crystal oscillator? Because as we know, in crystal oscillator we are having the more frequency stability. We are having the more frequency stability, and also we are having the more quality factor. And most important thing, the frequency is independent of your temperature, or it is independent of your transfer parameters, or it also independent of your power supply. Especially as you have seen already in your LC oscillator or RC oscillator, the problem of LC and RC, it means there the frequency stability is not good. In LC and RC, the frequency stability is not good. Because why the frequency stability is not good in your LC and RC? Because your capacitor or inductor or resistors, that depends on the temperature. If the temperature may variation of temperature, the value of capacitor, resistor, inductor will change. If the value of your inductor capacitor changes, they will change the frequency. It means, as in your LC oscillator or RC oscillator, your capacitor, inductor or resistor, that depends on temperature. If the temperature changes, the capacitor, resistor, inductor value changes, they will change the frequency. It means the frequency stability is not good in your LC and RC oscillator. Also, the Q factor is also very less. But in your crystal oscillator, they are having more frequency stability. And also, as I said, there are more quality factor, and most important thing, it is the frequency stability very good, because your frequency or output frequency is independent of your temperature, or your variation in the temperature, or transfer parameters, or your power supply. That's why we prefer the crystal oscillators. Maybe I covered everything in the last class, and today we are going for the lecture number 6. You are going for the lecture number 6, and especially in the last 3-4 classes, you have completed the sinusoidal oscillators. You have completed the sinusoidal oscillators. As I said in the beginning, in broad, you can classify 2 types of oscillators. One is called sinusoidal, another one called the non-sinusoidal oscillators. And we have completed the sinusoidal oscillators. And as I said, in sinusoidal, depending upon the feedback, in feedback which components you are using, you have studied about the 3 types of oscillators. It means depending upon the feedback path, or depending upon the feedback network, what components you are using. If you are using in the feedback L and C, that is nothing but LC oscillator. If you are using in the feedback path R and C, that is nothing but RC oscillator. But if you are using in the feedback path crystal, that is nothing but crystal oscillator. These are the studied about in detail about working, application, advantages, disadvantages about the all 3 types of sinusoidal oscillators. And today we go for the another one type oscillator, that is called non-sinusoidal oscillator. Today we are going for the non-sinusoidal oscillator. Look here, their name indicates their meaning. What are non-sinusoidal oscillators? The oscillator, they will give the output that is other than sine wave. You have studied already about the in detail about sinusoidal oscillators. Now you are studying about the non-sinusoid oscillator. In non-sinusoid oscillator, the oscillator which will produce the frequency or output that is other than sine wave. It may be square wave, or it may be your sawtooth wave, it may be a rectangular, or it may be triangular wave. That type of oscillator nothing but the non-sinusoid oscillator. Very simple. It is also a type of oscillator. In this oscillator, your output is other than sine wave. It may be square wave, or it may be your triangular wave, or it may be rectangular wave, or it may be sawtooth wave. This type of oscillator nothing but the non-sinusoid oscillator. It is a type of oscillator. In this oscillator, your output is other than sine wave. That is nothing but non-sinusoid oscillator. Especially in this non-sinusoid oscillator, we are studying about the most important type of oscillator. That is nothing but multivibrators. We are studying about the multivibrators. Multivibrators. We are studying about the multivibrators. We are studying about the multivibrators. Look here, actually, what are multivibrators? As I said, it is also, it comes under the, it is a type of non-sinusoid oscillator. The multivibrator, it is a type of oscillator. It comes under, it is a type of non-sinusoid oscillator, because here the output is square wave. It means the output is other than sine wave. The multivibrators, it is a type of oscillator, it is a type of circuit. They will give the output only the square wave. It is a circuit or device, they will give the output as square wave. That is nothing but multivibrators. The multivibrators are a circuit or an oscillator, it will give the output only the square wave. Or it is a type of non-sinusoid oscillator. In multivibrators, we are studying about the three types. One is about a stable multivibrator. A stable multivibrator. And another one is about a stable multivibrator, and another one is about monostable multivibrator. Look here, the third one is about bistable. Third one is about the bistable multivibrator. In these three types of multivibrators, but according to your syllabus, we are only studying about the bistable multivibrator. In multivibrator, we are studying about there are three types of multivibrators. One is called a stable multivibrator, second one is called monostable multivibrator, and last one is called bistable multivibrator. And we'll go for in brief about this. Actually, I said we are having only your syllabus is about only bistable multivibrators. But if we, for the knowledge purpose, in a stable multivibrator, nothing but the output is not stable, the output state is not stable. Because as I said, the multivibrator, it will give the output only the square wave. It will give the output as square wave. But in square wave, only there are two conditions: 0, 1, 0, 1, 0, 1. It means in a stable multivibrator, the state output states are not stable. It may be 1 or 0, 0 or 1. The output is not stable. Or output is not constant. That is nothing but that type of multivibrator, but a stable multivibrator. It means in a stable multivibrator, the output is not fixed. The output is not constant. It may be 1 or it may be 0. That is nothing but a stable. But in monostable, the output is one state is stable. It be 1 or 0. Here, both the states are not stable. Both the states are not stable. Here, one state is stable. That is called mono, means only one state is stable. It be 1 or 0. and it means one state is constant or stable, and in bistable both the states are stable. It means the output may be 1 or 0. Here both the states 1 and 0 both are stable. Here any one is stable, here no one is stable. I am saying about output. Here output is not stable. Here only there are two outputs, 1 and 0. Here only one output is stable. Here both outputs are stable. This is about in brief about the multi-operators. Actually, in your multi-operators can be constructed by using the transistor and also by using the IC5. It means if you want to construct the multi-operators, you can use the transistor or you can use the IC5. But according to your syllabus, they are given about the IC5. They are given about the IC5 timer. IC5 timer. Look here, it is so important in electronics IC. Already you studied about the op-amp. It is also one type of integrated circuit. In the same way, you are giving more importance to the IC5 timer. Actually, what is how we can define? It is a most important versatile linear monolithic integrated circuit. What is IC5? It is a so important versatile and linear monolithic integrated circuit. What I am saying? IC5, it is a so important, versatile, reliable and linear monolithic integrated circuit. Correct? And especially why you are using this? Because it is very easy to handle and also it is very cheap. It is very cheap. No cost. Cost is not more. Very less cost. That's why we prefer the IC5 timer. And actually, what is the main function of this? This will produce the more accurate and stable time delays or oscillations. They give the time delay or oscillations. The most important thing, why you are using IC5 timer? They give the most important, they produce the more stable and accurate time delays or oscillations. The most important function of your IC5 timer is about they give the more accurate and stable time delays or oscillations. Right? And especially in the IC5 timer, they are invented, they are discovered, or they are the 1970 they have discovered or developed, and the company that is Signetics, the Signetic Corporation, they have developed this IC5 timer. In the 1970s, the Signetic Corporation, the company, they have developed this IC5 timer. Actually, this IC5 timer, it consists of 23 transistors. It consists of 23 transistors and 16 resistors, and 2 diodes. I am saying inside our 555 that contains 23 transistors, 16 resistors and 2 diodes. This is the board in brief, and you can apply the voltage 5 volt to the 18 volt. You can apply the 5 volt to the 18 volts. This is about some important points about the IC5 timer. Basically, the IC5 timer, it is a so important, versatile, reliable, linear, monolithic integrated circuit. And its most important function, it will produce the more accurate and stable time delays oscillations. And they have invented or they have proposed, developed in the 1970s the Signetic Corporation that contains 23 transistors, 16 resistors and 2 diodes. And the range of voltage, that is 5 volt to the 18 volts. data. Now we go for the most important thing about pin diagram. We go for the pin diagram of your IC table 5. It is so important. They will ask in exam, write the pin diagram or draw the pin diagram of IC table 5. Pin diagram of IC table 5. Actually, it is an 8-pin diverging line package. How we are studying about op-amp. It is also an 8-pin IC. Your IC table 5 is also 8 line. It is also 8-pin diverging line package. It is also 8-pin. It is also an 8-pin diverging line package. And we go for the pin diagram. As we know, it is having the 8 pins. It is an 8-pin integrated circuit. And we go for in detail about pin diagram. This is pin number 1, 2, 3, 4, 5, 6, 7 and 8. IC table 5. If we can write here the pin number 1, the important thing, pin number 1, that is nothing but the pin number 1, that is ground. The pin number 1 is ground, and the pin number 2, that is triggering. We are applying the triggering voltage. And pin number 3, that is always your measure output across pin number 3. Pin number 3 nothing but the output. And pin number 4, that is reset. And pin number 5, that is control voltage. Control voltage. And pin number 6, that is about the threshold. And pin number 7, discharge. And finally, the pin number 8, that is positive VCC. This is about the very simple about pin diagram of your IC table 5. You are asking 2 marks, write the pin diagram, draw the pin diagram of IC table 5. The important thing, pin number 1 is nothing but ground. Pin number 2 nothing but you are applying triggering voltage. Pin number 3 always measure the output. Pin number 4 is nothing but the reset pin. Pin number 5, that is nothing but the control voltage. Pin number 6 nothing but threshold voltage. Pin number 7 nothing but discharge. Pin number 8 nothing but positive VCC. Pin number 8 nothing but positive VCC. Same thing I written here because it is not space is not right here. Written here. Pin number 1 ground. Pin number 2 triggering. Pin number 3 output. Pin number 4 reset. Pin number 5 control voltage. Pin number 6 triggering. And pin number 4 is about pin number 6 is threshold, and pin number 7 is the discharge, and pin number 8 is positive VCC. This is about the very simple pin diagram about your IC table 5. This is your pin diagram of IC table 5. And if you know the pin diagram, it is very easy to understand the block diagram, how you are actually working up your IC table 5 timer, how your table 5 timer works, what is the working principle of, or what is the block diagram of your IC table 5. Now we go for the functional diagram, or we go for the block diagram of your IC table 5 timer. We go for the IC table 5 timer. You can go for the block diagram. Block diagram of IC table 5. Actually, as I said, you people, it is so important functional diagram or block diagram of IC table 5. How actually IC table 5 works, and basically it contains inside your IC table 5 that contains the two comparators. That contains two comparators, and also it contains an SR flip-flop. It contains an flip-flop, and finally it contains a transistor. Look here, before going for the actual block diagram of your tribal 5 timer, we know about how your comparator works and what is the how your SR works, and you know about transistors. Actually, you have studied in the comparator in detail in the type of operational requirement. Because if you understand the comparator and flip-flop, it is very easy to understand your isolated or 5 timer. And basically, comparator, it is an open loop configuration. It is a type of operational amplifier. It comes under, it is an open loop configuration. In comparator, you are not applying any feedback. In comparator, you are not applying any feedback. It is an open loop configuration. Better. And as you know, comparator will compare the two signals. The comparator will compare the two signals. And maybe you are remembering, this is nothing but your comparator, and you are applying the two inputs. It may be positive or negative. It may be V1 or V2 output. And the important thing in comparator, the output indicates, or the output is proportional to the, in these two inputs, which one is more, which one is greater than, that indicates. The output indicates in these two inputs, which one is greater. Or especially in comparator, it will compare the two signals. And because as we know in comparator, you are using open loop configuration. In open loop configuration, as we know, the output is especially for ideal op-amp, the open loop gain is infinity, but practically it is 10 raised to 5. It means if you apply very low voltage at the input, you will get the maximum output voltage, maybe in the time of 100 like that. But important thing, as in we know already, the output voltage should not more than the biasing voltage. That's why their output may be the positive saturation, or the output may be the negative saturation. But we know the working of comparator. The condition is that if the V1 is more than V2, then we get the V0 positive saturation. If the V1 is less than V2, then V0 is minus saturation. Or you can say if V1 is greater than 1, you get the 1, you get the high, or high and low. It means if you want to make it the comparator high, you have to apply more voltage at the non-negative terminal. You have to apply more voltage at the non-negative terminal, then you got the positive saturation, or you got the high output across the comparator. This is about in brief about comparator. And now we go for what about flip-flop. Actually, you are studying in detail in your digital electronics about flip-flops. The flip-flop, it is a memory device. It will store the 1 bit of information. It will store the 1 bit of information, or it will store the 1 bit of data. And actually, basically, it is a sequential circuit. Flip-flop is a sequential circuit. It will store the 1 bit of operation, or it will store the 1 bit of information, or 1 bit of data. It is a memory storage device. It is a memory storage device. Maybe you have seen in computers where are memory. In that memory, you are storing ones and zeros. Basically, you are using the flip-flops. Actually, you are using registers. The register on the board, it is a combination of flip-flops. It means it is a 1 bit storage device, memory device. And basically, this SR on the board, set and reset. SR on the board, set and reset. And we will go for that in brief about that. Yes, or, and you are having two outputs, Q and Q1. They are always complement each other. If it is 1, it is 0. If it is 0, it is 1. Always these two are in complement. Example, S is 1, R is 0. In that time, your Q is set and Q1 is 0. And whenever it is set, it will store the 1. If it is reset, it will store the 0. Whenever the flip-flop is set, means it will store the 1. If it is set, it will store the 0. Okay, right? 0, 1, 0, 1. It means whenever Q is 1, they will set means they will store the 1. If it is set, means they will store the 0. This is about in brief about your SR flip-flop. They will store the 1 bit of memory location or they will store 1 bit of data information. This is about in brief about SR flip-flop. Now we will go for actual your block diagram and also working of your IC table 5 diagram. Now actually I said it contains in 2 comparators. It contains 2 comparators. It contains 2 comparators, and as I said already, oscillator it is having a SR flip-flop. It contains an SR flip-flop. And here S R and Q bar. Q bar. This is output. And as usual, we are measuring all these output factors in number 3. And here we are measuring we are applying a transistor, that is a discharge transistor. Pin number 7, that is discharge. And remaining about here, you are applying yes. Actually, you are applying a voltage divider network. You are applying this pin number 8, positive VCC, and this is your ground, pin number 1, ground, and this is your pin number 2, triggering, and this is nothing but your pin number 5, right here, control voltage, and here it is about threshold pin number 6, threshold, and this is your reset pin number 4, reset. And actually for the comparator you are using some reference voltage. That reference voltage is taken from this resistive voltage divider network. The specificity of your IC table 5, it contains a voltage divider resistive network. That contains a voltage divider resistive network. And why it is called 555 timer? Because it contains a 3 resistances. Their value is same, 5K, 5K and 5K. Why it is called 555 timer? Because that contains 5K, 5K, 5K. 3 resistors they are connected in the series, and that acts as a voltage divider resistor network. That acts as a voltage divider resistor network. Right? And especially for the this is our comparator 1, comparator 2, and especially for the comparator 1, we want some reference voltage. That reference voltage is taken from this voltage divider network. That is nothing but we are using 2/3 times VCC. Here you are considering the 1/3 times VCC. It means for comparator 1 and comparator 2, you will take some reference voltage. That reference voltage is taken from this resistor network. This reference voltage is taken from this resistor network. This is about in brief about the block diagram. And as I said, it contains 2 comparators and a ESR flip-flop, and it is having a resistor network. And why it is not double 5? Because it is having 3 resistors that are added in series, their value is 5 K, 5 K. And as usual, as we know, your output is in terms of square wave, and square wave means the output may be only the two conditions. The output may be higher or low. The output may be the higher, and as I said, always we measure the output across pin number 3. Always we are measuring output across the pin number 3. Now consider the comparator 1. And as I said, your output that depends upon these two input comparators. Your output that depends upon the output of these two comparators. For example, consider the comparator 1, and as I said already, always in comparator 1 we want the more voltage across the non-inverting terminal compared to the inverting terminal. Then only get the comparator 1 are high. We want comparator high. We want the comparator to be active. In that time means in these two voltages you are applying comparator, the important thing, whatever applying the voltage for this threshold, that should be more than the 2/3 times VCC. Then only you get the comparators 1 is high. Once again repeat, for comparator 1, we want output should be 1 or high. When we get more, when we get the high output from the comparator 1, the thing is that you have to apply the threshold voltage that should be more than the 2/3 times the VCC. Then only comparator 1 is high. And if it is high, means what happens? If it is high means the flip-flop is set. Flip-flop. This is the flip-flop is set. Set means it is 1, this is 0. It means your output is low or 0. It means whenever comparator 1 is active, in that time what happens? Your output is 0. And also the thing is just your threshold voltage is more than the 2/3 times VCC. In that time you will get the output is 0. And if you want to make it output 1 or high, then what have to do? Consider the comparator 2. In comparator 2 also, what we want more voltage? We want more voltage at the non-inverting terminal. Means you have to apply very less voltage across the triggering. You have to apply very less voltage across the triggering. Always you want more voltage across the non-inverting terminal. It means for comparator 2, you have to apply the triggering voltage. That voltage should be less than the 1/3 times the VCC. You are applying some triggering voltage. That voltage should be less than the 1/3 times VCC. Then only you get the, now in that time you get the comparator 2 is 1. If it is 1 means R is 1. R is 1 means what happens? R is 1 means that is reset. Reset means it is 0, it is 1. In that time you get output is high or output is 1. It means very simple, because I said your overall triple pipe that depends on these two comparators. These are also called as input comparators. It means if you want the output is 0, means you have to apply some voltage. You have to apply some threshold voltage that should be more than the 2/3 times VCC. You have to apply the threshold voltage that should be more than the 2/3 times VCC. In that time you get output is 0. And if you want output is 1 means you have to apply the voltage, the triggering voltage that should be less than the 1/3 times VCC. Then you get the output is high. Or right here the threshold voltage. The threshold voltage is more than the 2/3 times VCC. The output is low. If the triggering voltage is less than 1 by 3 times VCC, the output is high. This is important. It means in simple way, your output that depends upon the comparator 1 and comparator 2. In simple way, if you want output 0 means we have to apply some threshold voltage. That voltage should be more than the 2 by 3 times VCC, and in that time you get the output is 0. If you want output high means you have to apply the triggering voltage. That voltage should be less than the 1 by 3 times VCC. In that time you get the output is high. This is about the working of your IC 855 timer, and important thing, it contains 2 comparators and a flip-flop. Now we will go for final last about the bistable multivibrator. How we can construct the bistable multivibrator by using your IC 855. We will go for the bistable. Go for the bistable multivibrator using IC 855. And actually I said it's so important. It is a switching device. It is also called as flip-flop. It is also called as latching device. The bistable multivibrator is also called as flip-flop. It is also called as latch. It is also called as a switching device. The bistable multivibrator, as I said in the beginning, you are in 2 states are stable. Bistable multivibrator, it is a switching device, and it is also called as flip-flop. It is also called as latch. And how we can construct by using your IC 855 timer. You can construct the bistable multivibrator by using an IC 855 timer. And as I said already, it is your pin number 6, and this pin number 1, that is ground, which is already. This is pin number 5, and this is pin number 3, always measure output. This is pin number 7, there is no connection, and this is pin number 8, we are applying positive VCC, and here applying an triggering. This is IC 855. This is the triggering. This is the reset. And here using an resistor, they are called roll-up resistor. And also using a switch here. And this switch is about this is applied to the positive VCC. This is R, and you are applying an actually I said about already. You are using an reset, and also you are using an positive VCC. As I said here, pin number 1 is ground, and pin number 2 is current triggering, pin number 3 is output, and pin number 4 is about reset, and pin number 5 about, as you know, about control voltage, and pin number 6 about triggering. Pin number 6 is about grounded, pin number 6 is grounded, and pin number 7 is no connection, pin number 8 is about VCC. And how it works? Very simple. And as I said, 2 people already. We want the bistable multivibrator. Means we want the output should be set or reset. Set means output is 1. Reset means output is 0. Here, basically, this triggering and result terminals are connected to this R. They are called pull-up resistors. R is nothing but they are called pull-up resistors. Why it is called pull-up resistors? Because these two resistors are connected to the positive VCD. They are called pull-up resistors. If these two resistors are connected to ground, they are called pull-down resistors. These two resistors are connected to the positive VCD. They are called pull-up resistors. And actually, in the initially what happens? The triggering and reset pins are high. Basically, triggering and reset pins are high. And if you want to connect, if you want to make it the triggering voltage connected to the switch, if this triggering terminal is connected to the switch through the R, then what happens? The triggering terminal is 0. The triggering terminal or triggering voltage is 0. If this voltage is 0, then what happens? It will set the flip-flop, and whenever this flip-flop is set, we will get the output is 1. In the same way, if you want to apply the reset pin to the key, can use this. You remove this key, you connect this key like that. Then what happens? The reset pin is low. Whenever your reset pin is low, means your flip-flop reset. If the flip-flop reset, will get the output as 0. It means, as I said, in bistable multiplier, it is also called as flip-flop. The bistable multiplier is also called as flip-flop. In flip-flop, there are two conditions. It may be 1 or 0. It will store 1 or it will store 0. But in the important thing, here both the states are stable. Both the states are stable, and also it is 1 only. When it becomes 0, means you have to apply some triggering voltage. Then only it becomes 0. It is 0 only. When it becomes 1, you have to apply some reset voltage. Automatically it should not 0. Automatically should not 1. You have to apply some triggering or reset voltage. Then it becomes 1, becomes 0, 0 becomes 1. For what I am saying, 1 and 0. That is not changing itself. You have to apply some triggering or reset voltage. Then only they will change 1 to 0, 0 to 1. That is something but in simple way of your bistable multiplier. Once again repeat, it is very simple. It contains triggering and result voltages, and your output that depends upon triggering and result pins or voltages or pulses. And you are using the resistances. They are called pull-up resistances. And important thing, as I said, if your triggering pin or triggering voltage is connected to the ground, then what happens? The triggering pulse is 0. Your triggering terminal is 0, or your triggering is low. If your triggering is low, means what happens? In that time, what happens? Your flip-flop is set. If the flip-flop is set, it will show the 1, or your output is 1. If your reset pin is connected to the ground, if this reset pin is connected to the ground, then what happens? The reset is low. Whenever reset is low, means what happens? Your flip-flop is reset. In that time, output is 0. It means we can set and reset the flip-flop while connecting the triggering and reset pins to the ground. If you connect the triggering terminal to the ground, in that time your flip-flop acts as set. If you are connecting the reset pin to the ground, in that time your flip-flop acts as reset. It means the important thing about bistable multiplier, it acts as a flip-flop. And flip-flop nothing but it will store the 1 bit of information or 1 bit of data. It will be 1 or 0 data. If you want to output 1, if you want to store the output 1, in that time your flip-flop is set. Flip-flop set means it will store the 1, flip-flop reset it will store the 0. This is about in brief about your working the bistable multiplier. Data, important thing, data depends upon the triggering and result voltages. That depends upon the triggering and result voltages. Data. If a triggering is connected to the ground, that is low. If it is low, your flip-flop is set, then give the output as 1. If your reset is connected to the ground, then it is low. In that time, flip-flop reset will give the output as low. This is about in brief about your bistable multi-operator. And maybe you have completed this oscillator chapter. In the next class, you go for some problems, because as I said, one problem is fixed in exam for 5 marks, and in the next class, you go for the problems on oscillators. Thank you.